You probably think that you know how the universe works. Let's check. Imagine any planetary system. You'll most likely see something that resembles our solar system, a massive star with smaller planets rotating around it, right? But wait a minute. Scientists recently discovered an exoplanet, WD-1856b, from the Draco constellation, which is 7 times the size of its star. It's comparable in scale with a volleyball revolving around a tennis ball. In this video, you'll find out what celestial bodies don't fit into the usual model of the universe. Can a planet swell up? Will Earth become larger than the Sun? And most importantly, how can a planet be bigger than its star? To answer this question, we need to clarify a few things. You've probably figured out that in astronomy, there's more to it than what it seems at first glance. A star isn't always something big and shining, and even a planet-like body can suddenly turn out to be a new star. So, how do scientists tell them apart? For ease and comparison, they use the mass of our Jupiter, which is approximately 1.9 kilograms multiplied by 10 raised to the 27th power. With space babies, or objects that don't exceed 10 masses of Jupiter, everything's quite simple. They just can't be stars because they don't have enough energy. With giants that are many times larger than Jupiter, everything's also quite easy. Nuclear fusion in their depths is usually so great that there's no doubt that we have a real star in front of us. But apart from that, there's the so-called gray area where things get somewhat tricky. Objects ranging from about 10 to 16 Jupiter masses can really surprise you. Such bodies are often classified as brown dwarfs, meaning objects with characteristics of both planets and stars. And to find out what they really are, experts have to fly into space and dissect them. Literally. Real stars have strong thermonuclear reactions going on inside. Well, inside planets, these reactions are either weak or don't exist altogether. However, in the case of brown dwarfs, it's almost impossible to find out all of that from Earth. The question gets trickier, as even this rule has its exceptions. So, what are the planets we can't distinguish from stars? Meet Corot 3b. Do you think it's a star or a planet? Wait, I'll give you some time to think. Its mass is 22 Jupiter masses. That's why it's no longer in the gray zone. So, does that mean that what we see is a star? It's not all that easy. Now scientists tend to believe that Corot 3b is a massive exoplanet. We might be dealing with some kind of a statistical fluke here, as this planet is located at a distance of 2,200 light-years from our Sun, so it's not really that simple to obtain that much data about it. However, such objects still remain one of the most mysterious things in the entire universe, because they just don't fit into the usual model of the universe. But maybe our standard model should be slightly modified. Here is Kappa Andromedae b. In 2012, this object was captured near the star Kappa Andromeda, and its mass is about 13 times bigger than that of our Jupiter. We're used to thinking that something that revolves around a star can't really be a star itself, but the temperature of Kappa Andromeda b is about 1,700 kelvins. This is although the temperature of brown dwarfs doesn't usually go beyond 900 kelvins. Does this mean we're dealing with a small star revolving around its big sis? Unfortunately, scientists can't answer this yet. However, the thing we know for sure is that it's physically impossible for a planet to be larger than its star. So when we talk about giant planets, we consider not their mass, but their volume. In this case, how big can the planet be in terms of its volume? Some planets are very close to their stars. That's why they can overheat and swell up to abnormally large sizes. For example, Kelt 11b is an exoplanet about 1.5 times the size of Jupiter, but at the same time having only 19% of its mass. the star it revolves around isn't bigger than our Jupiter. Besides, in astronomy, there's such a thing as fluffy planets, gas giants of large diameter. One of the most prominent fluffy exoplanets is HAT P1b, discovered in 2006. It's about 1.36 times larger than Jupiter in diameter, but its weight is just half that of Jupiter's. This means that the matter this exoplanet is made of is 3 times lighter than water. For a long time, HAT P1b was considered the largest exoplanet. But in 2009, scientists managed to find the real giant of all giants. The diameter of WASP-17b goes beyond any of the known exoplanets right now and is 2 diameters of our Jupiter, which is almost 140,000 kilometers. But how is this even possible? Well, it all boils down to density. WASP-17b is now believed to have the lowest average density among all exoplanets, only 0.1 gram per cubic centimeter. For comparison, the density of Jupiter is 1.33 grams per cubic centimeter. That's why WASP-17b is the well-deserved leader in the battle of diameters. However, all these objects are at a distance of thousands of light years from us. Can we observe similar processes somewhat closer? For example, could the Earth suddenly become larger than the Sun? Sure, at this point it sounds like a script for a not-so-successful futuristic movie. But hold on a second. The recently launched James Webb Space Telescope has shed light on the mysterious object GJ1132b from the Vela constellation. And it turned out that at various stages, this celestial body looked like different objects of our solar system. At first, GJ1132b resembled Neptune. The gas planet was surrounded by a dense atmosphere, and due to its proximity to the star it revolved around, it expanded to enormous proportions. But after several billion years, the radiation of its star made this planet lose its atmosphere. The insatiable star destroyed GJ1132b to the very core, and this celestial body gradually turned into something like our Earth. Its radius was bigger than the Earth's by only 13%. Our Earth and that exoplanet resembled each other in many aspects. They had the same density, and their atmospheres were similar and had the same pressure. Some astronomers even considered GJ1132b to be the Earth's twin. However, now it looks more like Saturn's moon Titan. Due to severe volcanic activity on the planet, a secondary atmosphere was formed. Now its surface looks like a cracked eggshell with wisps of smoke coming through it every now and then. So, could the Earth repeat the fate of GJ1132b if they were so similar at some point? Our orbit is far enough away from the Sun, so in a few billion years, our star will most likely turn into a red giant and swallow several nearby planets, including Earth. That's why our home planet is unlikely to become the new GJ1132b, unless something completely unpredictable happens. For example, the Earth's orbit could be changed by a so-called intergalactic star. These space rogues aren't bound by gravity to any galaxy and wander around the universe. One such traveler destabilized the orbit of planet WD1856b that I mentioned at the beginning of the video. As a result, it moved very close to its star. And do you know what to do if you want to be the first to know about an intergalactic star getting closer to our planet? Subscribe to Riddle.